match the following. Column 1 we have chalcopyrites ore, galena, PBS ore, argentite, once again ore, malachite. So ores are given in column 1 and we are asked to match with the process which are used in the extraction of the metals in column 2. Sulfide ore, carbon reduction process which we use, self-reduction process, leaching followed by displacement, basic carbonate. So when we go for option A, we find chalcopyrites, which is nothing but CuFeS2. In other words, it is a sulfide ore. Therefore, A goes with P. And during the extraction of copper from this CuFeS2 when we use, during the roasting, we also get certain amount of Cu2O as we have discussed, so that the Cu2S from the ore combines with the Cu2O that is formed during the roasting to give copper metal and sulfur dioxide as a self-reduction. So thus, self-reduction or carbon reduction is generally not used for the extraction of copper. Leaching, no. Basic carbonate, no. So therefore, A goes with PR as the options. Then we have galena. Galena is nothing but PBS, lead sulfide, and we know that lead sulfide is the one during the roasting will be converted into lead monoxide. With lead monoxide, it undergoes self-reduction to give lead metal. So thus, it is a sulfide ore. Therefore, P is right and is also undergoing self-reduction. Therefore, R is right. But this PbO formed, this lead monoxide that's formed during the roasting of lead sulfide galena can also be reduced with coke, which gives lead and carbon monoxide. Thus, lead also can be extracted from lead sulfide by carbon reduction process. Therefore, for carbon reduction, what do we have? Q. Thus, the answer for B, we have PQR. Then let's go for C. What do we have in C? Argentite. Argentite is nothing but Ag2S, an ore of silver. So it's a sulfide ore. Therefore, P becomes the answer once again. And this Ag2S, for the extraction of silver, it is treated with sodium cyanide as the solvent in the presence of oxygen, so that this argentite dissolves in sodium cyanide and thus leaching is involved to give sodium argentocyanide, NaAgCN taken twice, soluble complex will be formed. And this soluble complex is then treated with the reducing agent zinc metal, where zinc being more electropositive than this silver, displacement takes place to give Na2ZnCN4 and silver is obtained. So thus, extraction of silver can be made from argentite by cyanide process, MacArthur Forest process. So therefore, in addition to that, it is a sulfide ore. We have carbon reduction, no. Self-reduction, no. Leaching followed by displacement is there, and it's not a carbonate. So therefore, S also becomes the answer. This all corresponds to what is called S. So therefore, the option C goes with PS. Then we are left over with D. What is D? D is malachite. And malachite is a basic carbonate. It is CuCO3.CuOH taken twice. So thus, it is a basic carbonate. And we have in the options in column 2 as a basic carbonate. And the basic carbonate is T. So thus, T is one of the options. And during the extraction of copper from this basic carbonate, during calcination, as it is a carbonate ore, cupric oxide is formed, and this cupric oxide can be subject to reduction with coke to give copper metal. So thus, carbon reduction is also possible. And we have carbon reduction in column 2 as Q. So thereby Q is also the right answer. So thus D goes with QT. Thus A we have two options P R. For B we have P Q R. For C we have P S. For D we have QT.